Alright, YouTube, got another sort of an incremental on Rover. So we've got the whole, this is, previously you saw this component of Rover. This was a single suspension arm subassembly operating. All these things are hooked up over a CAN bus, and I got the whole system running minus the other three wheels. So the next thing to do is to screw on the encoders and do the magnets. I had a video about that recently. So I've installed the other encoders on here. You can see it there. And oh, there! Look at that. So Rover is coming along. And yeah, so I've installed the encoder, and then you hook up the encoder wire. And this is the VESC motor controller. So the encoder goes into that one right there. And this is the VESC. This is the 4.12. You'll also find that I've soldered an extra capacitor right there. Please see the thread on reboot.love about that. And then here are the delicious batteries for Rover. But what I'm showing now is the encoder calibration. So I've got VESC Tool. I'm going to click off my headlamp for a minute. So this is VESC Tool, and I can happily provide to you the XML files to load onto the motor controller so that it's ready for these motors on Rover. But once you've done that, you need to calibrate the encoder. So I've got USB hooked up, I've got the encoder hooked up, I've got power hooked up. So the VESC could try to spin this, but in field-oriented control mode, FOC mode, if it doesn't have the correct orientation for this stored, it's not going to work. So we go into VESC Tool and we click Detect Encoder, using 10 amps for these motors. If you're using smaller motors, you might do 1 amp or 2 amps. You can do whatever's not going to burn out your motor. Then I click Start Detection. This is going to turn the motor. Hit OK. And you can see now that the motor is doing a little bit of movement. So what's happening is the VESC is energizing the coils without trying to figure out how to spin the motor. But then it's reading the encoder, and by energizing the coils and reading the encoder, you can figure out where the magnet is on the motor in relation to its coils. So this is the calibration process that needs to happen for every one of Rover's wheels to make it spin. So that will complete shortly. Hopefully my phone will not die. There we go. That completed. So now it says that we have these numbers: offset 268 degrees, ratio 7.0, inverted. We hit apply, which is going to save it up here into the GUI. But now in order to write the GUI onto the drive, we hit download motor. Now that's saved. Now that's saved onto this controller here, and we can disconnect power, and then when we hook up the CAN bus from Rover, this will spin properly. But before we do that, I'll just demonstrate to you. You can also use the GUI. So we're going to say 5,000 RPM, and hover over that, and then I'm going to click on that. And let's see, maybe I did something wrong. Yep. So that's actually a bad calibration. This is what I get for shooting a video. Detect it again. So hopefully this works. I might have to get in and debug, but if I ever talk about calibrating the motor, this is the procedure I'm talking about. Let's see. These are my favorite. Some of my favorite tires, by the way. These are the Demolisher tires from rc4wheeldrive.com. Demolisher. Ugh. These are, you see that? RC 4-wheel drive. So these are really cool tires. I mean, look how big they are compared to my hand. So these are really big off-road tires. Okay, so I'm gonna hit apply. Now let's try to drive the motor. Oh, this has another issue here. Okay, the motor is stalling out. I think it's because the timeout is set to 10 milliseconds. I just clicked over to App Settings General. We were on FOC. App Settings General, and then this timeout is 10 milliseconds. I can set it to 100 right now, and then download app parameters. This GUI I think is unnecessarily complex for what I'm using it for. I would love a little Python script to do this, but okay, I think it works. Okay, good news. Actually, so the calibration worked the first time, but these the calibration worked the first time, but these controllers have an RTOS running on them with a safety check, and the safety check was set to 10 milliseconds, which is what I run on Rover, because we send packets every 1 or 2 milliseconds. But the USB program on here that I'm running, VESC Tool is open source as well, though it's GPL licensed. This program doesn't send the updates fast enough, and so you can't use 10 milliseconds. So for testing on your bench, you want to change that. And then once you're done, go back into General and change the timeout to 10 milliseconds. Because on Rover, the updates come every 1 or 2 milliseconds, and so from a safety perspective, if your Raspberry Pi craps out, you want the motor to shut off. So typically when I'm done, I'm gonna hit write app and write motor. These are XML files you can also get from me if you haven't previously saved the config onto your VESC. And then just for fun, we'll do it one more time. So this is 5,000. Oh, well, right. I saved to the 10 milliseconds, and now it shuts off. That's a safety feature of the VESC. So, ta-da. And I'm going to do that with 2 more motors. So we already did it with this one. Then I'm going to hook them up to the CAN bus adapter, which is here. This is it. This is CAN bus adapter. It's really simple. It's open source. There we go. The CANable USB CAN adapter, open source, CANable.io. It's by ProtoFusion. This is protofusion.org. There we go. I like this CAN bus adapter. So the whole idea is technically you could do this over USB, but it seems like it would be a pain and not high speed. This is the remote for Flutter, and this is Flutter. This is my Kickstarter. So you hook up the Flutter receiver over USB. This is the Flutter receiver. There we go. I have a bunch of these. I'm shipping them. You can't really buy them from me now, but maybe someday. It's an open source wireless controller. So that hooks up to the Raspberry Pi, and then the CAN bus adapter hooks up to the Raspberry Pi. This was HDMI for debugging. This is what the motor controller looks like. This is the VESC. These are $100 a piece from an eBay seller called Maytech and other sellers as well. This is open source, designed in KiCad, and it works. Also definitely would recommend checking out the ODrive. So I just haven't used my ODrive. I have one. I really support Oscar and what he's doing. But I landed with the VESC first, and I'm just sticking with what works for me right now. So next step is calibrate this motor and this motor. and put it together. And then I should have a functioning Rover V2. Super excited. If this weird video is interesting to you, I got a website. It's called reboot.love. And the whole point of that website is to give people who think this is cool a place to talk about it. And I want to make open source robots that do farming and reinvent society. Just get a bunch of friends together and live by our farming robots. That's what part of what Reboot's about. So anyway, this is Rover version 2. Thanks.